Good afternoon, everybody. So glad to see you all here. Familiar faces, friends, and colleagues, new faces as well. Let's start to speak about the SMRs once again. So it's a very famous and interesting topic that everybody is speaking about. And first of all, I'd like to speak about the business aspects and specifically about the supply chain. Because this has been reported by Dr. Sharon and other persons, this is one of the most important things that we can look at. First of all, I would like to say some words about the context and the interest in these SMR technologies. So it's well known that large-scale projects are costly, the construction time is long, we have a lot of problems with them. The payback period is long as well, so we have this magic solution. And everybody is thinking about it with more than 80 different designs, that it will solve all our problems. So typically, lower construction risk and associated problems, shorter construction time, installation, lower absolute capital cost, reduced power grid requirements. If I can take an example of Counsellor construction, for example, for the Unit 3, the assembling of the primary loop, reactor, pressure vessel, steam generators, all the pipings, it took about 15 months. When we speak about Reading 200 reactor of integral type, it's just delivered on site and mounted, so we can reduce easily by a factor of 3 the construction time of the primary circuit. This SMR will provide the steam, so it's completely an autonomous system. Big questions, big challenges. Let's go back a little bit to the history of the nuclear energy. You remember the first reactors, the first generation, these were the prototypes. They were interesting. We were jumping as a generation 2, the massive construction. We have a good example of mass construction of reactor in France, 900 megawatts, 1300 megawatts, in Russia 1000 megawatts, VUR thousands, so other projects. So it was interesting. However, some disasters came into this game and additional safety measures were integrated in the design. So all the design became costly. This is a major problem of the large-scale NTPs typically. Even though they are interesting from the cost point of view of the final kilowatt hour. So we cannot definitely cut the cost of the safety. We cannot reduce the safety systems. So we need to find other options how to optimize this SMR program, because we are launching it now. We are in the beginning of this era. So typically, due to this challenging and changing market conditions, governments have their own role to play in this game, because they have their own strategical view on the future of the energy of each country, and so they can play their really important role in this part. So typically the pictures that I observe in different countries, and India as well, that we have 3 different poles of this main stakeholders. So typically the government, which requires major and economically competitive technology, vendors who expect certainty and a clear request from the government, big orders, and as well as suppliers who are expecting the orders from both of these players. So typically we have such a small resistance between these parties. So to get an economically competitive SMR, we need to get this picture. So typically, what is the recipe of such economically competitive and interesting SMR? First of all, it's a major technology, because it will provide some at least guidelines on the initial costs that shall be involved in this program. Clear state engagement in the SMR program. So typically specific lands and sites that has to be chosen, because we spoke this morning about this topic. It's very important to have a site to place these SMRs, otherwise we will always stay on the paper. Feasibility studies and associated studies that will allow to get the final cost, because probably it's one of the main questions that I hear every time. What is the cost of the SMR? I don't know, actually, because it depends upon the local site, it depends upon the volumes of orders, it depends upon the numerous factors. The prototype will be costly. For example, in Russia we are constructing now 2 units of SMR equipped with 55 megawatt electrical reactors, and And we have recently signed a contract with Uzbekistan on the delivery of 6 SMRs. So what will be the final cost? We will see in several years. So typically, we have done the estimates of all this picture, and from the pilot project to the standardized project, what we are expected to see, we can reduce the costs by half, maybe more. So it depends on typically the volume that we will get, the order at the end. So main innovative approaches, at least for these reactors in the future, what we see is the standardization of equipment design and manufacturing based on the pilot project. So it will appear soon, at least in Russia. And the vendor partnership with the local industry that will allow to go down these costs. So let's speak about some innovations and general proposals that Rosatom is providing for partners and clients all over the world. So typically you maybe know about our integrated and comprehensive order that is provided for our customers. It means that it includes all the supplier chain which surrounds energy solutions. We have done it for the large-scale NTP. So depending upon the involvement of the local industry, local government, the matureness of the local industry as well, we can choose à la carte all the solutions and pick up the appropriate one for a specific customer. So nowadays we are doing the same one with a Reactor 200 reactor, which is our key reactor in the SMR lineage. We have as well thorium SMR. I will provide you with more information in the future about it. So typically it's a lead bismuth cooled reactor which can use and handle thorium fuel. And a little bit upgraded GRES 300 reactor, lead cooled, of a greater capacity of 300 megawatts. But that one I will put in my next presentation in the future. So typically the same package is available for the SMR deployment. Let's jump a little bit inside and look at the different aspects, what we are providing with it. For example, multi-D software packages which provide the support starting from the contractual discussions till the commissioning of the unit and simplify all the interaction. Human resource development. You can imagine that large SMR program, and when we speak, for example, about India, it's hundreds of SMRs potentially be needed here. We need to think about that. We need the staff to operate all these plants. We need the staff to maintain these plants. We need academical staff. And so everything is provided by Rosatom. We have some specific branches that can open in the countries of presence to help perform this stuff as well. All the associated universities to Rosatom can open such branches and provide qualified personnel. Fuel supply. It's one of the important topics as well, because yeah, you have an SMR but you don't have a fuel, so it's not interesting. 12. Rosatom subsidiary provides fuel for all Russian designed reactors and foreign design as well. So typically on this right side you can see the fuel for the Reactor 200 reactor. It's already operational. It has been tested, has been proven, and we have implemented some new technologies as well within this scope. So typically when we speak about Reactor 200 reactor, the operating cycle is about 6 years. For the 14 units, it's about 10 years. So local industry involvement. It's a major point of interest, and I guess for India it's the most important one. So even so, Rosatom has all the supply chain in-house. When we speak about large volumes and large SMR deployment, it's really important to implement the localization procedures. So Rosatom is partnering with the local industries and ready to provide its knowledge to make it happen in each country. For example, typically you can see that this is a main reactor which is transported on site. So this nuclear steam supply model is provided, but everything else can be manufactured and constructed in the country. I have a good example of what has been decided for the Uzbekistan project, and it has been stated in the intergovernmental agreements where we are engaging ourselves to supply the part of equipment and materials from Uzbekistan and coordinate work regarding the localization in this country. So we are ready to do everything to make this SMR dream happen. So that's just pretty all, and I will conclude on I would say and highlight that all the elements of the supply chain are important, and we are always forgetting to mention human resource development, because typically we have a basic definition of it. We don't mention human resource development. Human is a key element. The second step, Rosatom has all the necessary competences and can provide to the foreign countries, and specifically for India, to provide with this knowledge and make this SMR program happen. And even if we have such ambitious program as India stands for the future. Thank you so much.
Thank you. So the aim of my talk will be a general overview of the French policy on nuclear energy, and also on what are the business beyond in the country, but also in the frame of international collaboration for international projects. So, to summarize, in France, we have a strategy for energy which is based on 2 pillars. It's a national low carbon strategy with the objective to reduce the greenhouse gas emissions with a target of 50% of reduction in gross emission by 2030 compared to 1990, and achieving the carbon neutrality in 2050. So there is a particular emphasis which is placed on the decarbonization of the transport sector and housing in France. The second pillar is the pluri-annual energy program. So the share of electricity in the energy mix is expected to increase up to 39% in 2035 compared to 25% today. And beyond, there is an objective of 54% of the global energy mix being covered by electricity in 2050. Okay, this is the picture of the installed electricity capacity in France since 2007. So the nuclear part is close to 60 to 63 gigawatt installed power. The hydro is the second main part of the production. Then the thermal power by fossil fuels, mainly gas, is decreasing in time, and of course some renewable like wind and solar are increasing in time. But what is also interesting to consider is on the next slide. Yes, this is the trend of the electricity production since 1995. So nowadays, 90% of the electricity production is already decarbonized. But you can see that the part of nuclear in the total power produced is as high as 65 to 75% depending on the time. And of course, this is the major advantage of this mix of energy in the country. And the objective is to keep such a mix in the future. So, yes, what are now, beyond this production, what are the nuclear facilities in France able to support such objectives and the capacity to increase in the future the electricity production? So today, 57 nuclear power plants are operated by EDF. There are 8 R&D centers operated by CEA, Atomic Energy Commission, 6 fuel cycle facilities from the front end up to the back end of the fuel cycle operated by Orano. There are the nuclear components for the nuclear power plant and also the UX fuels production by Rosatom company. And we also have 3 waste repositories in operation for low-level waste, on 1 future deep underground disposal is currently under licensing by the safety authority. This should probably be achieved in 2026. So the supply chain, now we could consider what is the business behind this picture. So 220 workers in France to supply the energy, the electrical energy by nuclear. A supply chain of about 2,500 companies, from large groups up to small and medium-sized entrepreneurs. So if you want to have detailed information on this ecosystem, you could connect to the website of the GIFEN group. We find all the necessary information to understand this ecosystem. So, what is the nuclear trajectory ahead 2050? Reactor life extension beyond 50 and 60 years. Up to now, they are only allowed to operate for 40. But this is the strategy number one. The second one is that the Parliament has approved the nuclear investment to launch 3 pairs of EPR2 reactors. This has been decided. On EDF, they started to build the financing plans to operate such projects. There is also a strong encouragement of innovative SMR on reactors. So in France, the French government has invested up to 2030, 1 billion euros to support 12 startups to cover different types of technologies, and the objective is to commission the first concrete of a pressurized reactor in 2030 and to launch at least 1 reactor prototype of a different technology. Fast breeder reactor, molten salt reactor. So the fourth major point is that there is a renewal work which has been engaged by the Orano company for the back-end facilities in order to rebuild a reprocessing plant in La Hague in the north of France to succeed to the current one which was built at the beginning of the 80s. And also, there is a work engaged to build the new European Union Convention on enrichment facility. And so, of course, last but not least, the Atomic Energy Commission will conduct an investment program to maintain the capacity in the nuclear sector. So, now I would like to invite Mrs. Bermann, French ambassador, in order to talk about what would be the business about this and beyond this situation.
Thank you. Good afternoon, everyone. So I am the president of the WNE, World Nuclear Exhibition, which is the largest in the world. Last year we had 24,000 visitors. We had 88 nationalities, up to 800 exhibitors, and we plan to do even better next year. It will be from 4 to 6 November 2025. And of course it's a business exhibition, and it's an opportunity to connect with everyone in the nuclear sector. And some companies told me that during those 2 or 3 days, it's the possibility to meet as many people as they would in 6 months or 1 year. So it's really important to be there. Apart from this business meeting, of course we will have also roundtable keynotes about the current nuclear, well, the big reactors of course, but also SMRs, it has been mentioned before, and also the future, well, such as fusion, and it will be discussed for the first time. And I know it's interesting for India because you're cooperating with ITER, and ITER of course will be part of it also. We will discuss, of course, delivery skills, and that's the reason why we are inviting students, universities, and research centers. Of course, there will be a startups village, but we will discuss also other applications of nuclear, such as nuclear medicine, agriculture, and space. So we will cover everything. And of course, you need skills, but you need financing also. And since there is a real renaissance in the world of nuclear, we are engaging with some bankers, investors, business angels, and so on for the financing of nuclear. So it will be addressed for the first time during this exhibition. So I know there has been some Indian companies that are involved in it, and I visited a lot since I've been in Mumbai. I will go to New Delhi tomorrow. I met in the IAEA with the DAE, and so I hope there will be, well, as I said, a strong presence and also an Indian national pavilion to give more visibility to what India is doing. So, welcome to Paris, and I wish you a good meeting now, and put the dates in your agendas. Thank you.
Hello. So, a very good afternoon to all. I'm Vivek Javani. I work in the infra, energy and materials industry at Dassault Systems India Limited. So what I'm going to discuss today is lifecycle management for SMR using virtual twin technology. I'll take this opportunity to introduce our company first. We are a company, we say that we combine art, science and technology. Sustainability is at the core. We have around 24,000 people, out of which around 5,000 are based in India. We have centers in Bangalore and Pune. We are basically, we have revenues of around 6 billion euros, and that is how we invest in R&D. We have a very strong ecosystem of partners with whom we deliver our virtual twin products, and globally we have 350 customers, unique customers. We are a French company basically. We are headquartered in Paris. We also have a headquarters in Boston and Shanghai. In India, our main centers are in Bangalore and Pune as well. So the belief with which we work is that virtual twin extend to improve the real world. There is no undo in real world. So especially in the topic what we are discussing, like nuclear, where safety and quality words come very often. It is better we don't do physically first, but we do virtually first. That is the motto over here. A legacy is something like this. We were the first to introduce 3D based design. CATIA, SolidWorks are some of our known brands. We went for a digital mock-up in 1989. Then in 1999, companies like Toyota started leveraging our product lifecycle management solution. And in 2012, we transformed our focus to a platform-based approach. We follow the tool-based approach, and we'll explain how this platform-based approach actually helps nuclear SMRs as well. Sustainability is a part of our DNA. Our business goals are also aligned to sustainability, and also the way we work is aligned to this particular goal. Now coming to the topic of nuclear energy as a potential. So we work a lot with renewable energy today. What we understand is that while we are scaling up solar as well as the wind energy, we need to provide a constant base load to this along with this particular thing, wherein the nuclear power would be very important. So these are a couple of quotes why today the clean energy goals, the ambitions which cannot be achieved by only this means of solar and wind, we would require the nuclear as well. So how do the SMRs actually come into this picture is something like that. The nuclear power plant will have a big capex investment and a longer time to basically develop. Here we are talking about small and modular reactors. Okay, so this will actually help us to have overcome the cost overruns and construction delays to start with. They would be fundamentally safer, they would be scalable, and it would actually fit in the grid directly because the output would be somewhat similar to the thermal plants, and probably we would be able to find new usages which we do not have today. So this is why today probably we have more than 80 SMR designs already going on in the world, and multiple countries are actually involved in this particular development process. So what are the drivers, main drivers and objectives when we talk about an SMR life cycle starting from the design to the end, or if I'm getting to an SMR? Evolving regulatory framework. This is a new topic. The regulatory framework, as we see, is evolving today. Hence, the licensing part of it is to be critical. Even there are efforts to uniform, to make it uniform across. But as a company, as a OEM, if I'm going into production, model-based certification is going to be the enabler for it. Competition is going to increase because more and more players, not for big pharma, but in SMR we will see which are coming. We saw a lot of them. So the time to market cannot be as long as the big pharmas. So virtual twin engineering is something which will come into the picture. When we talk about a worldwide market, we would have to produce for scale. So our supply network would have to be very strengthened, and ultimately it will all boil down to the levelized cost of electricity also. So here standardization and industrialization would be important. These are the main drivers and enablers which, as a Dassault Systems, we believe that for companies who are getting into SMR life cycle would be important for them. So what are the problems which we are trying to resolve when we embark on this journey? Architectural changes, time to market. We want to have our design cycle as shorter, obviously after taking care of the safety and quality. We want to have consideration from design to dismantling or design to decommissioning. Safety and licensing and the process for that, inline that. And we want to achieve the cost objective of development as well as the life cycle costing of this facility. Here we propose, or we profess that virtual twin technology is going to be the future of managing such kind of projects which can be started. So when we say virtual twin technology, what actually we talk about is generating a digital thread throughout the life cycle phases of this nuclear program. We start with the design. We want to design it right, engineer right, industrialize and manufacture would be the second step of it. Delivery, SMR delivery would not be like any other EPC project. There would be some specifics. Operation and maintenance, and finally decommission and dismantling. What we'll see in next 10 minutes, 15 minutes is how we actually try to do that using the virtual twin technology. Today, if we see the design cycle time of a nuclear power plant, it ranges to years together. That probably may not be a sustainable thing for SMRs. So what we are trying to do is optimize the product delivery time. Along with, we want to maintain the safety and quality of the product. So what do? We do not model only the reactor and the facility of it, but also we model the situation, the condition, the environment in which the facility is going to operate. So what we do is that we do this what if analysis, we do all this simulation before actually we get into any kind of production, and see how we can minimize the prototypes and the cycle time which actually it takes to design. We also have a customer case study or customer testimonial in this regard, which we showcased. When we talk about designing, we want a single platform, right from the requirements to a model-based architecture. We are designing system of systems over here, to the plant 3D layout, multi-physics simulation, other types of simulation, as well as instrumentation control, electrical, structural and civil engineering, to go on a single source of single source of truth, single source of platform. So this is the digital continuity what we are talking about between the concept design, basic design and the detail engineering experience. From requirement to 3D design, once we maintain this particular digital thread, what we will actually achieve is the traceability part of it. Traceability is, as we know in terms of nuclear manufacturing or nuclear industry, is a very important thing. That is what we will be achieving throughout this life cycle. So a very, very small example, very, very small video I want to play, wherein we'll start with the geology part of it and entire thing, including the environment, which we are trying to actually do it on a platform, okay? So that my baseline and variability are taken care, my configuration and change management, partner collaboration, the entire supply chain who is working on that, my reviews which are happening, integration reviews, my safety reviews, my licensing is taken care of. All these elements are basically taken care of on a single platform, and I don't need to basically use different point tools and then integrate them together to achieve this particular goal. And just run it a bit fast over here. This is an example of how civil design is getting integrated to the actual site condition and the product part of it. So once we do this design part, we have now designed it, how do we industrialize and manufacture it? Okay. So to become actually competitive, we will have to make sure that the cost part is also taken into consideration. And here we have some lessons to be learned from the automotive industries, which got industrialized, say, a decade and a half ago. We start with modularization. What do we mean by modularization is, we are going to have variants of this particular SMRs which are different and same altogether based on the country, geo or variant which we are actually giving. So this is how we'll have to design this modular part. And here, how platform helps is that we can have modular assembly engineering, constructability studies and finalization, everything on a platform. So when we have a new variant, we can adapt it very quickly going ahead. Productization of SMR is easier said than done. Configuration management, because we deal with a highly regulated industry. Again, if we are able to have manufacturing facilities which are actually have designed in a virtual way, our operations are actually done virtually, testing and inspection is also planned virtually. We can actually accelerate this particular process and actually try to reach the goal of production. And to achieve this, we will need standardization of the parts and parts catalogs across the SMR variants, what probably we are doing. So on the same platform, we should be able to do part cataloging, and the suppliers, say hundreds of suppliers probably are which should be acting. It should be a requirement-driven procurement. We want all these things to happen on the same platform. Coming to industrialization, okay, here we want to do the streamlining and optimizing of processes, and here is the stage which will say that we have a factory virtual twin. We not only model the product but also the processes, tools and supply chain virtually, so that we can achieve excellence in this regard. Industrialization is basically we want to go for some kind of mass production. So here 3D experience tool will actually act for supply collaboration as well as the quality monitoring. These are the 4 steps. This is nothing but the how we do the quality conformance for this entire process, which is of vital importance, and how not only the OEM or the vendor, but the entire ecosystem can come on the same platform basically to expedite this entire process. Once we are out of this manufacturing, we go to the TPC or the project part of it. So what we want to do over here is the engineering, procurement and construction. We want to digitalize this process. Probably today we are using point tools. Say for scheduling we have a tool, for scope management we have a tool. ERP obviously is going to stay, but the monitoring of cost probably we have another methodology. same as the commissioning part of it. We want to bring this all together in an integrated project management system. Today, the EPC is in IE&M industry is very important, and Dassault is managing some of the biggest and largest projects probably which we are seeing. So now SMR delivery. Okay, so project delivery in a normal EPC context and nuclear would obviously be different. What the message, what we want to drive through this slide is configured product definition, whatever we want to have, we want to maintain it throughout the life cycle. Sourcing and industry, equipment standardization, we already discussed. We want to have manufacturing and standard assembly plans. Okay, this is just a few seconds I've done. So that the message I want to communicate is we do not just model the practice part of it, but also the installation part of it. We actually do it, the delivery part of it, we actually model it, test it, finalize it, and then actually we test the ground. That is the message to it. Similar is the case with the testing and commissioning, supply chain management, site planning and local engineering. Whatever uncertainties are basically expected at a site, I want to test it in my environment beforehand, and then probably this is where I want to actually go ahead and do it. All the other elements like procurement, preparedness of activities, monitoring, the message is that I want to bring this and I want to deliver SMR as a complete facility, physically as well as virtually. Asset transfer is something what I want to do in the operations phase. So we started with design, then we went to the manufacturing, and then we went to the EPC and SMR delivery. When we come to the operations, I don't want to lose the data which actually I have generated throughout my life cycle. I want this data and make a digital handover of the plant to the O&M authority who is going to run this plant. And even after the delivery in the O&M phase, I want to have configuration and complete health monitoring on the same platform. So this is what we will add value in the operation and maintenance. This is the summary of how in a life cycle a platform can, what value it can add. So basic virtual twin key values if we see, these are the 5 top what we can actually integrate in that. Start with model-based system engineering. We ensure digital continuity throughout the life cycle. We ensure configuration and variability management on the platform. We maintain this digital thread throughout the process, and also we have a cloud-based, secured and scalable platform which not only the OEM but also the other authorities basically can come on and collaborate and deliver right now. A small customer story I would just want to get it very quickly. Narya is basically, they are into extra small advanced modular reactor, and they actually went, it's a French startup basically, okay, and then when they were doing, they wanted to actually have their production to be started by say 2030. So the design cycle time length was very critical to them. They adopt this 3D experience platform to do what we just talked about, and I think the design phase was completed in a record time. And today they are gaining benefits for deploying this virtual technology right from the start of the design and development, concept design to the end of the design phase. Some of the other customers which I'd like to mention, obviously these case studies are many of them are publicly available. You can look on the net. Our ITER EDF is one of our customers. European National Source and CREM. So these are some of the customers. We have a stall over here. I would invite whenever you get time to visit and get details on these topics additional to whatever I have discussed. So this is it about one topic which I wanted to share.
Thank you very
so much.
Good afternoon, everyone. Welcome to this afternoon session of panel discussions. We had a very good, fruitful session in the morning, I hope this session as well would enrich each one of us present here. I also like to thank Nuclear Business Platform for giving me this opportunity to do the panel discussions. So, since morning, we have been emphasizing enough of the nuclear requirement of the nuclear energy for India due to its economic growth. We know that it's going to be one of the top 3 economies very soon. We have the target of 100 gigawatts to fulfill by 2047 to transition to the net zero by 2070. We have seen all those numbers. There is a lot of gap which needs to be filled between the renewables, fossils, and all the energy, all the other energy mix that we need. This is a massive task, and we are here to discuss how we are going to achieve that kind of scalability, that kind of surmount the complexities of nuclear energy. So the first half we focused on the domestic requirements of the nuclear energy, and we also discussed a lot about how it can be scaled up. In this panel discussions, we are trying to explore a possibility or see the potential of whether the nuclear energy from India could be exported to the world, because ultimately the net zero requirement is not a local requirement or a national requirement limited to India. It applies to each and every one. So there are a lot more new countries that are thinking about entering the nuclear energy, and we do see a possibility, do see a potential of actually helping those countries out, exporting from this established design and supply base to the other countries. We also have extensive experience in terms of how to set up a nuclear power program itself. So there are a lot of opportunities that could be explored, and that is what we would be doing in this panel discussions. We would try to explore different strategies, different ways of making it possible in terms of how do we export the nuclear energy from India, or make nuclear energy in India for the world. So that more or less sums up the theme of these discussions, and I would like to invite all the eminent panelists with me here on stage, starting with Mr. Shashidhar Kuppar, Additional General Manager from NTPC. We have Mr. Subhash Singh from BHEL, and we have also Mr. N.M. Nadaf from Volgin Industries Limited. Good afternoon, all the panel members. I am delighted to have you on the stage. Before we set out the discussions, may I request each one of you to give a brief introduction and brief introduction of your journey. May we begin with Mr. Subhash?
Singh. Am I audible? Yeah, I am Subhash Singh. I am working as an additional general manager at BHEL. I have worked for 5 years at Nuclear Power Corporation prior to BHEL. Then I have joined at BHEL, and I am working in Nuclear Business Group unit in DHL.
Thank you, Mr. Sashidhar.
Yeah, my name is Shashidharpa, Additional General Manager working in NTPC, presently working in Nuclear Cell, which is based out at Mumbai. Before joining NTPC, I was working in Nuclear Power Corporation for 7 years. After that, I joined NTPC Engineering Group. There I worked around 15 years in engineering department. Basically, I am a retail graduate. From past 2.5 years, I am working in nuclear cell and associated with Russia.
Thank you, Mr. Nizam.
My name is Nadav. I represent Volgin Nagar Industries. I am basically a mechanical engineer, trained in BRC for nuclear engineering, and then I worked on India's first nuclear submarine and I am also a defense officer, retired naval officer, vice admiral. I was a program director for the India's first nuclear submarine.
Thank you, sir. May I begin this discussion with sharing one particular scenario that so far we haven't thought of exporting the nuclear reactors or exporting the nuclear energy from India to outside. So I would like to begin with Mr. Nadav. What do you see could be the changes in terms of policy or in terms of other structures that might be necessary before we even contemplate the export of nuclear energy?
India, we have got now stabilized on the PHWR reactors. 220 megawatts of PHWR is one of the very old reactors, proven design. This reactor possibly can be considered for the exports. Earlier, we have tried this, but due to various political situations, possibly this has not happened. But once the government opens up this, I think I'm not the very competent person to talk about this particular business, but Mr. Sharan is here. He will be able to tell more. But I suppose we can do this provided there is a government agreement on this.
Thank you, sir. Mr. Shashidhar, may I invite your comments on that?
Yeah, basically India from past around 60 years it is dependent on mainly on Indian pressurized water reactors that will be done by started from BRC, then NPCL, and now talking about the BSR. This is also again 220 megawatt which was done long back. BRC as well as NPCL they have evolved this technology from 220 to 540, then around 700 megawatt. Yeah, basically this reactor basically depends on natural uranium. It works on natural uranium. It doesn't require enriched uranium. So it can be a well thought that the BSR can, otherwise even PHWR can be exported, where in which country there is a necessity of cleaner energy demand, having a deficit of enriched uranium or uranium facility. There India can be a major source for exporting to that country, because if you see in world around 31 countries nuclear reactors are installed. Still around 30 countries are willing to take the nuclear reactor from the countries, where India play a key vital role providing this PHWR based technology. It is having a well proven technology and having a, if you see their track records, there is no incidents such notable incidents. So it can be as per the government bilateral relations with that particular country, it can be exported to particular country. So even in addition to that, PHW 700, BSR is the best model, which is again a 220 megawatt, and it can be suited to any location where large reactors are not able to place it. So there again is the best move from the Indian government to promote a BSR.
Thank you, sir.
Hello, just this nuclear power, this demand will mostly come from developing countries only. So, for cost effective wise, this PHWR, those will be cost effective as compared to LWR or other reactor PWR. So that will be it for exporting PHWR from India.
That's very true. In fact, looking at the maturity of the whole design cycle, maturity of the even the component manufacturing, the other areas that are available, I think that could be a right path to follow, provided policy changes, required policy changes as suggested are done. That brings me to the next logical question about the actually supply chain management, because we saw in the first half that we as a nation do need immense nuclear energy to be supported by other energy mix, and we'll definitely have our hands full as far as the manufacturing, supply chain and all other stuff is concerned. So it would be interesting to see or interesting to actually evaluate and comment how far we would be able to support in terms of exporting that same technology while catering our in-house requirements. We have all the prominent representatives from OEMs available here. They can throw a better light on what do you think could be the readiness of our supply chain in that terms, or the gaps, or if there is any enhancements required. I'll begin with Mr. Sylvie.
Okay, as far as country-wise DHL is concerned, in India, DHL has already installed 195 plus gigawatt in India, and about 12 gigawatt capacity in outside India. So, and DHL has supplied electric commissioned all turbine sets from 220 megawatt to 540 megawatt to 700 megawatt. All ratings turbine sets, all are manufactured, supplied, electric by DHL. And as far as the nuclear side, the nuclear product side is concerned, steam generator, reactor headers, end sheets, these nuclear products are manufactured and supplied for as far as Indian nuclear plants are required. So I think as well as for instrumentation side, if you see for 700 megawatt complete instrumentation package also DHL has supplied. So I think Indian industry, they are well capable, they are having sufficient capacity to meet the global demand or export the nuclear plant. So they are having sufficient capacity. They can manufacture all nuclear primary side as well as secondary side equipments in India. So, and for outside projects are concerned, DHL has executed projects in 89 countries and exported 12 gigawatt of power. So DHL has exported all sort of gas-based projects and thermal projects projects, around 12 gigawatts are supplied, directed and commissioned. So in Indian industry they are having sufficient experience as well as all such manufacturing as well as logistic experience for overseas.
Thank you, Subhash sir. I would like to extend that I'd like to hear the views from Mr. Nadaf as a OEM manufacturer. Do you think we need more hands inside our country to actually support this whole idea of, let's say, export?
In the morning panel, Mr. Srikanth brought it out very clearly, and Mr. Sarina also, saying that the Indian industry has always listened to the call from the Indian requirements. So, and therefore the present status of indigenization has taken place. Now, industry will rise to these requirements, whatever the requirement comes, whether it is the indigenous requirement or the foreign requirements. But the basic issues are 2-3. One is that any organization, any industry will need assured continuous order, because there will be some investments requirement to upgrade the facilities, get more manpower, etc. And if we are going for lowest bid kind of a contracts, then you are not very sure whether you will get the next order, and therefore Indian industry will hesitate. But if you have kind of a MOU signed between the organizations and you are given an assurance that there will be a continuous orders on a specific components or specific equipment, definitely the Indian industry will invest more and cut short the time period, because as we go on manufacturing, our expertise will come to us, and we will reduce the time frame for supplies. So that will happen. So we need an assurance on the continuation of orders. That is one. Second point is that cash flow. If the current contracting systems does not encourage a good cash flow, so we have to borrow money from the banks, and then we have to invest in this and then produce the answer. That today's situation is that you get only 10% in the beginning and 90% is only after delivery. Now that's not a good practice, because we have to borrow it from the banks, and our understanding of the whole affair is that we are all working for the banks. That means whatever the profit we make it, we have to give as an interest to the bank. That's not a good practice, and it is ultimately the customer has to pay. It is not we are going to pay from the pocket. So this kind of a situation for easy cash flow, like the earlier days, as we achieve the milestone of work, we used to get the payments. If we come back to that particular thing, then it is easier for us to do the work more efficiently and more promptly, and we will have less burden of borrowing it from outside. The third issue is, in a certain reactor equipment, there are critical materials. Now these critical materials are mostly, today we are not manufacturing them in India. They have to be imported. Now if we have to import, then the quantities become smaller. And if the quantities become smaller, either we are levied higher charges or delay occurs in the delivery of the materials. So we have been suggesting, like earlier practice of NPCI, that some of the critical materials should be bought in bulk by NPCI and given it to us as a free issue materials. Or if you give a bulk order to us for a component or equipment, then we can approach to the material supplying organization outside and get some kind of a quantity discounts and assurance of timely supply. That will help us. So these kind of measures, if we are given, then I think it is easier for Indian industry to respond quickly better and the timely. So this is what will happen. Thank you.
Thank you, sir. Finally, Mr. Shashidhar, if you have any thoughts further to add to it.
Regarding Indian manufacturing, it is well matured enough to supply Indianization with Indianized condition, and it is supplying from the past so many years. And now time has come to gear up, because we have to, our target is to achieve 100 gigawatt of nuclear. And with this pace and with this same conditions, we cannot able to meet the targets. So now bulk order and critical component accessories, then long-term, short-term equipments that are going to be placed shortly, because India is gearing up in the two stages. One is in the phase of PSWR, which is already going on. As far as Indian nuclear industry is concerned, around 22 gigawatt is already under construction, and for that already some pre-issue material has been, as a pre-issue material from the DAE families, it has been ordered to some of the manufacturers. Some are going to come in sooner or later. As far as Ashwini is concerned, My Banswada is one of the projects we are implementing as a joint venture with the NPCL. So it has already started, and sooner or just within a few days, turnkey project will be awarded to them. So market will be opening up. This is the beginning. So within a short year of span, the lot of orders with respect to the PSWR. In upcoming futures, we will be seeing SMR orders also in the name of BSR we are going to see. So Indian industry has to gear up, and I feel Indian market is well competent enough to supply Indianized as well as global market also.
Thank you, sir. That logically brings me to the next question. We so far have been doing a few joint ventures with foreign players as well, but that was mostly to meet our in-house requirements. Potentially, can we see this as one of the strategy that we have a joint venture with them for Make in India? So I would again request Mr. Shashidhar if that could be a potential kind of a strategy, because seeing this as an opportunity to bring in many different design capabilities in-house, many different manufacturing capabilities in-house. What you may feel about it?
Yeah, nuclear industry is now has the gaining up and rapid capacity addition is required. So we can't rely on only one technology. We have to diversify our capacity addition. First through Indianized pressurized heavy water reactor, then BSR, then SMR. Now another pipeline is, another way is opening shortly through fast breeder reactor, which is fuel is thorium based technology, which is under final stage of commissioning. When it proves, India will be the one of the advanced stage thorium based reactor we will be operating. So that will open one more market for us to sponsor to other countries on thorium based technology, not only uranium based technology. So challenges are vital, and to meet that the Indian government as well as NITI Aayog as well as DA, Department of Atomic Energy, along with others, just like they have given one more PSU like NTPC, they have incorporated in the name of joint venture, because present Atomic Energy Act doesn't allow to as a private players. So along with the NPCL, we will be learning and we will be gaining. This will be the process for in future also. Similar kind of process may be taking place with respect to the private industries. So collaboration with in India, we are having a collaboration with other multiple technologies for in case case of PWR, we have in Kodamkulam, it is 1 into 2 into 1000 megawatt already it is running, and four more are in pipeline. That experience we are having. That is PWR technology based this thing. And one more we are having in Jaitapur, we are expecting EDF ERP, that European reactor we are expecting to soonly it is going to start. So similar kind of such type of reactors we are expecting in India. So on that basis we can, our manufacturing industries also it will be having a wide varieties of orders. So that will be a good vital source for Indian manufacturer to supply varieties of technology and equipments to depend upon the need of system.
Thank you, sir. I would extend that same question to Nadav sir with a twist that yes, in past there have been certain assessments done by different foreign players, international players about the localization capacities, whether the Make in India could be done in terms of major critical components and all the other supporting elements of the nuclear power plant. How do you see how difficult or easy it is to actually adopt that kind of tweak within the organization, within the manufacturing systems to cater to different and varied requirements? It could be, compliance to one particular standard, not just one particular standard, but multiple different country-specific standards. So, could this JVs potentially help them?
I will answer this question by my first-hand experiences on two topics. The first one will be on the design engineering part of it. For the nuclear submarine reactor, of course, there is nothing available, and so we had to start from the scratch, and we had to work from the bottom to the top. Now, while we are doing this, since we had no previous experience of compact reactors, etc., it would take years together to undertake the design, engineering and development of this. But if you get a hand holding, then because your capabilities of understanding, capabilities of design, engineering, etc., you can do this particular task in a very, very compact way and very efficient way, and it's a proven way, so that when you make a reactor out of this hand holding, then whatever the product you bring it out has an assurance or a guarantee of performance in a very, very good manner. Now, talking about the Indian scenario, I think we are capable enough now in the PHWRs, PWRs and BWRs. But what we need also is, say, molten salt reactors, high temperature reactors and things like that. Now, as far as these two technologies are concerned, molten salt reactor or high temperature reactor, we don't have much of a competence and knowledge or experience on this. So it will be worth going along with some proven technologist who has got some good experience or proven reactor by that particular design or technology and manufacture in India, or even if you have to buy a reactor, learn from it and then do it as a repetitive work in India is far better, far more assured and success story. But if we are hell-bent upon doing this and first principles and trying to design engineer in our own way, then there is no end could be seen. So this is an experience I am just sharing with you. Now the second example which I would like to share with you is, in every reactor there are critical components. For example, the reactor pressure vessel is a very critical, and this is a very critical component whose forging is not easy to obtain. These forgings are in bigger reactors, are very big, in more than 100 tons of forging, etc. And such forgings are only few companies in the world are making it. Now, if you focus and the government invests in this particular kind of thing, which our government has done it, then we are assured of critical supplies. Because these critical supplies, if we are dependent on somebody else all the time, then it is not a good solution. You can be into trouble at some critical moments, etc. So we have to identify certain critical materials, certain critical processes, and which we have to be totally self-sufficient. And the government has to invest in this and make sure that these facilities are created. Like I mentioned, the reactor pressure vessel. Similarly, steam generator tubes. Okay, these are critical components. So, and the materials, critical materials, especially reactor grade materials. Fuel is very critical. Unless you are self-sufficient in this particular domain, whatever program you are making, it will be only remaining on the paper and not realizing on the ground. And therefore, it is very essential for us to identify what is critical. If we are going to adopt a new technology, we must right from the day one. We must identify what is the critical material, what are the critical processes, where we can get held up, etc. And make sure that the resources are made available to our Indian people through whatever sources all over the world, and ensure you are standing on your own legs. Otherwise, all your programs will be failing.
Thank you, sir. I couldn't agree more to this because yes, there will be interdependence throughout the world on making a nuclear power plant. It cannot be a fully independent capability or capacity within a nation. Yes, it's not required to actually invent a wheel every time. Probably a good collaboration, a long-term collaboration can certainly help us go a long way. Taking cue from one of the earlier presentations from Mr. Alexandre, that it's not just the design manufacturing capabilities, it is also the manpower which is very, very important. So we may have all the needed capabilities in terms of infrastructure, in terms of manufacturing some component, but we also need a continuous stream, continuous supply of the expertise available at hands for us to go long term. So my next question on these lines would be to Mr. Subhash. How do you think that how can we strengthen our national policy or probably the national arrangement to strengthen that there is, to ensure actually that there is a continuous stream of expertise and manpower available to further this whole program, nuclear power program, for a long time.
Yeah, you correctly said that in India, in nuclear industry or any other industry, if an experienced person or some design person, if he retires, then sometimes all the technical expertise, capabilities goes with him only. So for that, now in government sector, in Indian industry, they are also taking many steps like that prior to retirement, 4-5 years prior to retirement, either he has been deputed in training stream, so he gives training to newcomers, so that his experience, his technical expertise, so it will be available to newcomers. So that some policy is being adopted in government sector, in few sectors. Other things are documents. design documents, those are also sometimes goes with that person who goes types all design documents go to them. So for that also centralized cloud-based systems are being developed by Indian industries. So all the design documents, all of being placed kept there only. So when a person goes from the organization or retires from, so those documents will be available for the newcomers. So like these steps being taken in government sector, so this knowledge is passes to new generation.
Thank you, sir. At this point, I would like to share an anecdote. Recently, I happened to visit one of the colleges to have an interaction with the students, and to my surprise, although it was not a very tier 1 kind of a location or tier 1 kind of a college, but to my surprise, at this point, students were not very well aware of how to enter into the nuclear sector. So that speaks about the level of awareness that we need to generate at this point of time if you want to go big into this program. And we often see good branding exercises done by all the tech companies, by all the other industries, but somehow we need to think gear up in this area, because I could understand somebody not being aware of nuclear, let's say 30, 40 years ago, but even at this point of time, there is a big crunch of the manpower. We do need manpower, and people are not even aware that there is a big opportunity existing there, and trying to just bottleneck one particular sector may not be a good idea. And to this, I can extend the argument that in terms of capturing the knowledge, as Mr. Subhash said, there is an opportunity that we need to have nationally. We need to have something like organizations similar to maybe INPO, maybe EPRI, who captures the operating experiences throughout the plants which is happening in the India. They are working on the detailed analysis of some of the very focused areas, like how to efficiently do the design or maintenance or operation, and they do keep on doing R&D and keep on coming up with new strategies. So I think there is a scope existing even in India. We can think of going somewhere down the line, down this line, to ensure that the old knowledge is always captured, old learnings are always captured, and in spite of the absence of people, there is a presence of process-driven knowledge management. I think that is my view. Maybe other panelists can support it.
Being a Ashwini company entering in, just now entered into the nuclear business at NTPC, and NTPC does not have design experience, even though he is having a thermal experience. NTPC has rich resource of thermal experience, right from the design to engineering, construction, operations. Whereas we have entered into nuclear, so we don't have R&D, we don't have engineering, design, then construction experience, then operation experience also. How we are going to do it? So for that we have chalked out and we have come up and we have with Saran sir and nuclear team how we are going to take up. That I'll put up into the small brief. So design engineering, for that it needs lot of experience, and not within a day it can be achieved. So it takes lot of years from past so many years people are working in the field of R&D, working in the field of design, engineering. So in one system it requires lot of years of experience. If you look at it, DARC, DAE, in one system around 20 years, 30 years experience people are working, and if new engineer is inducted, it takes at least 2 to 3 years to understand what the systems are there. So that kind of level of engineering design is required. If you come to the construction, the basic engineering construction knowledge, whereas nuclear industry is required. For operations, it requires licensing. You cannot go and I am a thermal operator, thermal power plant I am operator, I can go and do. It requires licensing before entering to the reactor. It needs at least one to enter into the control room from the beginning. At least 4 years experience is required to operate a nuclear power plant. That too with the rigorous examinations, training, after giving so much things. So it requires a lot of high skill knowledge is required. So within a single day it cannot be gained. So that is the one point. This thing, being a association with the with NPCL, NTPC is fortunate enough to have rich resource and rich knowledge people. So we will be gaining the design as well as engineering as the knowledge has been transferred from NPCL to NTPC. Whereas power sector, still it is a closed door, and they have to depend upon foreign collaborators or foreign companies which are staying in India. They have to depend on them. Anyhow, there is no restriction to learn. There are so many things are openly available in the nets. And only thing is on-job experience. You have to need a nuclear power plant. For that also there is a solution for that. Simulations are there. Where in simulation we can learn actually what things are happening in the reactors. That kind of knowledge is required, and to run a, construct a, design a, and this thing in all the fields where nuclear power plant technology is involved. Thank you.
Thank you. Thank you very much to our panelists. We came to an end of this panel and session.